I live in Stockholm and been doing that for 45 years. And being brought up in my youth in the northern part of Sweden, being accustomed to snow and darkness, it's still always an adventure to come to Kiruna. In the middle of nowhere. There is forest and marshlands and reindeers. And then suddenly there is a launch base, a space center. That is so strange. Still, every time I come here, I feel this is strange. This is really different from what you can expect. When I met my wife 10, 11 years ago, and she asked what I was doing, and I told her that I'm a rocket engineer, I launch rockets, she said that there is no such thing. Do we have that?
What do you want me to explain? We have a launcher with a rocket attached to it. A sounding rocket means it is not going into orbit, it is staying underneath. So we're basically following a parabola. We have a burnout of the first motor here, we have a second motor which burns out here, falls back, and then the payload itself with all the experiments on board. This will follow the parabola. And from that time, when the motor is basically burned out, we feel no acceleration anymore. The payload is falling into space. And we have so much speed from that moment that we go up to 260 kilometers. And then we fall back to Earth. And during that time, we have micro-G. When we come back towards Earth, at roughly 100 kilometers, and at a certain point it's slow enough, just by the air drag, that it injects a parachute. We have the payload hanging for the last 5 kilometers until ground, and it will land softly on the parachute before it lands. So that's the basic trajectory where everything happens. But this part up here, this is where we do the science. This is where we use the microgravity for 6 minutes to do our experiments. Right now we're basically in the preparation time of the campaign. All the scientists are arriving on Sunday, so in a few days. And we take like this calm time in between to prepare the rocket, to do all those necessary measurements. And when the scientists arrive, At the end of the week, then it will become busy again, and then they start preparing the experiments, and all the engineers and scientists are working with the experiments in the last preparations for flight.
First of all, we are here for a microgravity mission. You cannot create microgravity conditions on Earth. You can try to simulate it, but you cannot just push a button and you have no longer gravity here on Earth. And then before you go to the International Space Station to do long-term experiments, there is the sounding rocket as a research platform in between, where we can offer 6 minutes of microgravity.
Here on S-Range, the DLR Moraba, we are preparing many parts that are needed to fulfill the launch. We are preparing the rockets, we are preparing the parachute system, we are also with the recovery.
We're doing everything that the scientists need to have proper high-quality microgravity conditions.
So, and now we need to push it very careful to me, open it, because there are these connectors, and we really need to lift it. Yes.
There we go.
Okay.
Yes. There you go.
That was it.
Yep, all right. Good.
SSC is a state-owned company. So we basically run as a private company, but all the shares are in the hand of the Swedish state. With SubOrbital Express, we provide a platform for research under microgravity. Like, let's say, the big players, such as European Space Agency or German Space Agency.
For this mission with the Swedish Space Corporation, the role of ESA there is to make sure that the industry will provide the scientists and the state-of-the-art in instrumentation for performing experiments in space.
Okay, down, down, down.
Here we have the opportunity also for small companies or startup companies or universities have the possibility to get on the platform, to have the same service levels and to do real science under the same conditions.
You know, it's very difficult, especially from the scientific point of view, to be able to assemble a payload that is qualified for space or for microgravity.
It has been a great help for us to have this opportunity to test our technology and give us access.
So, welcome to S-Range, welcome to SubOrbital Express-3 campaign. The experiments are ready for flight simulation today. You will see that there will be activities in here and the operations is in the Science Center. All right, then let's get started. Have a successful day and good luck. Thank you.
First of all, I think this is something what is the cool thing with this job I'm allowed to fill. Yeah, so as the project manager or the mission manager, you have to understand each and every experiment to that extent that you actually know what is happening.
So shut it off manually.
So we have 12 experiments on board. So you have more than 100 scientists on site and customers.
Yeah, we have a few other things that we need to discuss.
And of course I have the commitment to deliver a successful flight. But on the other way, since I am also committed that this will be a successful flight, I don't take any risk on each of the systems, for example. So I want everybody to leave S-Range with a happy face and with great scientific data. And that's the goal. And yeah, there is pressure, but that's normal, that's a job.
In space, nothing is for granted. Everything can happen when you bring the systems at a level of stress and environment that cannot be tested easily on ground. So, of course, everybody is stressed because we hope for the best each time and each seconds of the microgravity time.
What you must not forget is, when you go through this process, you build an experiment for 2 years on the science requirements. You have only one shot, so you really need to be sure that what you're doing is correct, and that you don't leave any doubts that this experiment will work exactly for this 6 minutes of microgravity. That you really assure that everything works, and this is a very long process. So there's like a lot of testing done before. For example, spin tests, we need to balance the payload.
Why we fly this capsule? In order to re-enter in the atmosphere from space, you have to cope with extreme heat, and then you need a heat shield. Usually these heat shields are large and heavy. The idea inside this capsule is to make this heat shield lightweight and deployable. Once the motor is separated from the payload stage, the capsule is ejected, and then the deployable heat shield is deployed, actually like an umbrella, but it is made of material that can withstand up to 1500 degrees C. Once landed, we will use the GPS data and other beacons that are inside the capsule for recovering the capsule after the flight. Uno?
No, lascia così, basta.
No, appena attacco vede la carica, la corrente che passa.
Esatto, di solito.
Okay.
So now we start with GSC and check the status of one of the two battery systems, showing that it still needs charge.
Non è tanto 0,7 ampere.
No, è costante. We will actually need this detector on the helicopter just to verify where the capsule is. So now we can make a test and verify that it detects the capsule. Yes. It works.
We start stacking the whole payload again for the final time before launch. So we start with the lowest module in the stack. This is the mini Irene experiment, which is a re-entry body experiment. And this has the separation interface to the motor. And this is the so-called manacle ring. So it's basically like a V-band, which is then ejected after launch.
Und wir sind eine Space-Marke und wir bauen Space-Uhren. Und da gehört es dazu, dass du nicht nur theoretisch im Labor etwas berechnest, sondern musst auch den Praxistest durchführen.
Was machen wir? UTC?
We've been traveling space for more than 30 years now. But I think there was nobody actually who tested it. I guess there's some kind of list of things a watch needs to bring or have to go into space.
Also wenn du dir vorstellst, dass diese Uhr oder die Rakete, sie wird extrem hohen Vibrationen ausgesetzt, die hat eine extrem hohe G-Belastung von 12 bis 13 G und das kannst du nur eigentlich hier in der Praxis in der Rakete testen.
The question is why, but at the end of the day, people understand quite well that there's plenty of products out there in the world that have been tested in space already. So why not watches?
Mit 10, ob das draußen sind, noch eine fehlt. Ins Deutschland?
See? Nochmal.
Nobody really ever had a camera pointed onto a watch to see what's happening during zero gravity. We don't know actually, is it running faster or slower? And I think that makes us understand if we want to go to space in the future, we are prepared.
Now the party begins.
It's funny, the people will ask why we do have these small ceramic balls.
Because otherwise you don't see the vibration.
Yeah, you cannot see the vibration.
Exactly.
We want to have like such a machine in Grenchen.
Yep.
Where we can test the stuff on Earth. So we need to know what's happening during a launch. To simulate this in Grenchen, so yeah, that's where you can help us next year.
And the whole difference to all the other experiments, so all the experiments are just waiting for the microgravity, and for us is the most important is the launch itself.
Very cool. Getting nervous now.
Yeah.
I was like, yeah, man, that's a rocket, but now it's like, fuck's sake, it's a rocket.
So the Sami people have always lived in the north. And some are fishing and hunting, and some just use the handcraft. But the reindeer is like the center of everything.
Is it still today like that?
Yeah, in my family it is like that. Like the reindeer is the center.
Okay.
We move where they are. So in the winter we move down to the coast. It's called like that. Yeah. And in the spring we move up to the mountain with them. I don't think it's so beautiful in the cities, big cities, but here I can breathe out. It's so silent, so it's much better. Yeah, but the environment here is changing too because of the climate change. We get shorter winter and longer spring. And if it gets hot, then this snow will melt and get ice on the ground. And then it comes snow on it. And then the reindeer cannot dig or smell the food on the ground. So they will starve because they cannot dig through the ice.
Yeah. We've been here now for a couple of days already. We've seen, for example, the aurora for like a very couple of times only.
Yeah.
And only not that bright. So, but I guess you've seen it hundreds of times, right?
Yeah, I have. My mom always told me and my siblings that we are not allowed to scream, because if we scream, then the aurora is getting angry.
Oh, okay.
And we cannot make it angry. It's like so much power in it.
Okay.
So we don't scream, we don't whistle, we don't point at it. When we see it, we're just like, oh, you are there.
There is this two guys on S-Range who kind of work on the aurora, and they kind of physically, they do some measurements and stuff, and they do it since the last 30 years or something.
Yeah, something like that.
And they kind of measure the speed of the aurora.
Yeah.
So very interesting.
Yeah, it is.
The first night that we came here, there was aurora, and you get that lovely feeling inside you. It's something special, and it's emotional. Just seeing it is really exciting. You stay out until you just physically can't stay there because it's too cold. I'm interested in the stories behind the aurora, and in particular the sounds of the aurora, which is something that scientists used to say couldn't possibly happen, but now there are different ideas as to how it could happen.
We're essentially measuring space weather by looking at the light that's given off in the sky. All of the atoms and molecules in the upper atmosphere can emit light when they're excited by particles from the solar wind. And what we're really doing is making a weather map of what's going on up there. The aurora is the extreme manifestation of the emissions that we look at.
The rocket mission that's going on, I know that there are a lot of groups who are working on lots of payloads. It sounds really interesting, the microgravity experiments, the biological experiments that are going on. The fact that there's such a diverse range of people on this payload shows that it's a bit more democratic and open. You know, you have access. It's not just for the elite few. If you've got an experiment and you can justify why it should be on there, then you have the chance to launch your payload. That's good.
Let's undress her. Yeah. Beautiful. I do a last check now.
One experiment is about charges in planet formation. It's called CHIP, and they're investigating on particles which are basically forming new planets. They try to understand all the parameters, how planets are formed.
Okay. What is the right position? ECA1 is here, so like this.
We think that electrostatic forces between charged particles are very important for the early steps of planet formation. So you have collisions, you have friction, and you have charge separation.
Okay. Try. We as engineers, we are, of course, excited about the science, but our main interest is engineering.
So we have a video live stream from the rocket, and then we see, okay, the particles start to coagulate, we wait until they grow, and then we just can agitate them again to induce more collisions.
The science team's wish is to shake an experiment chamber during the flight.
We somehow do the opposite of what we should. We try to provide perfect microgravity condition, and on the other hand, we are shaking the rocket.
So if you shake something, you create vibrations. And that would mean we would disturb the other experiments. And for us, the biggest challenge was to make sure that we not disturb the other experiments. So we had to find out a way how to dampen these vibrations. You see here, in here we have the experiment chamber. So in this small box all happens, and we have that 4 times. The CHIP experiment as such is made from about 5,000 parts. To compare, I have found a number in that a modern car has about 10,000 parts.
So just to see how the challenge for the engineers is. I mean, how many engineers are involved to develop a car? Many more than SSC has.
As you can see now, they're preparing to put the motor on the rail, and this is done by this hydraulic trolley. So with this, they can pump, as you can see. They pump and they lift up the whole motor to orientate it properly in the rail. On the front of the motor, you can see some tiny T-shaped piece. It's an aluminium piece, and we call it the launch lug. And this launch lug is basically the thing that holds the motor on the rail. So this will then slide in the rail. There will be more launch lugs on the motors. They will slide in the rail and fix the motor on the rail. So this way it will stay there, and also later when we lift and lower the launcher beam, the motor cannot fall out.
This is fun. You will like it. You will love it.
Was wird jetzt hier alles durchgetestet? Jeder Schlauch ist an so einem Seil festgemacht, damit sie dann händisch abreißen können und alles auf einmal abreißen können. Das steht ja am Launcher auch so. Und wenn sie startet, reißt es ja dann auch automatisch ab. Durch das, dass es ja alles angeschlossen ist, wird das ja halt die Kommunikation, ob die theoretisch automatisch auslösen, die Experimente da drin. Und all das wird, glaube ich, jetzt da drin getestet. Also, siehst du nicht, aber ja. Siehst du da unten diese Ausbuchtung an dem blauen? Da sind die Kameras drin, die nach unten gerichtet sind. Also wenn die hochgeht, dann kannst du quasi, fängt sie an zu drehen und du siehst halt das Bild von oben. Das ist ganz cool, ja.
Stefan, did you ask ship to power on the module?
Yes, give me a second.
Mustang should be started. Just let me check.
Flight control from Esra's team. Flight control here. We've checked the nominal file. It looks good.
It looks a little bit like chaos, but everything is perfection.
-10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
They know what they do. It feels like a puzzle, but at the end of the day, it's like Lego. Every brick kind of finds its place.
It feels a little bit like Big Bang Theory.
And you are Sheldon.
Yeah.
No, those are all Sheldons.
All Sheldons, yes.
ALS is quite a complex experiment that deal with the evaporation of a droplet. The evaporation of droplet is important because will allow us to regulate, for example, the use of water in agriculture or to have better dispersions in the substances that we use in everyday life. The phenomena in microgravity that are linked to the evaporation are the absence of convections that will create, we hope at least, more uniform coatings. The possibility to have uniform coatings is important in many of applications. Think about the coatings that will be used as anti-radiation when during space flight.
So, Theo, the distilled water with the PDA, check?
Yes.
Okay. The label is done, and that's a check.
One of our smaller experiments on board is the experiment Musa from a science group from Costa Rica. And they're investigating on the Panama disease, which is actually affecting banana plants all over the globe. And they are using microgravity to trigger certain effects on these spores. And they try to find some initial conditions for a possible cure for this disease.
So this is a vascular wild disease that kills the banana crops, and it inhabits the bananas and kind of blocks bananas for actually growing bigger. It will just stop us from having more bananas for a while. It's just that I still can't believe like how my life has changed in the past 5 years, and then now that I'm here.
Phil.
And I just think that all the ways lead to space, you know, like you can do anything and have any background and then work in space if that's what you really want to.
Yeah, here we go.
We have another experiment on board, which is called Gebrüder, and they're working with diabetes research. And of course, it's not the idea to send diabetes-suffering people into space, but the idea is to create an environment for cells to trigger an activation of those cells, which might lead to a cure of diabetes.
This experiment is about how to treat diabetes in terms of using stem cells in combination with insulin-producing cells.
So our goal in this experiment is to see if microgravity can induce proliferation of beta cells, and if together with our cells this proliferation will be induced.
So this is the unit that we will put into the rocket. This is basically a flying incubator. Once we put this hood on top of this, you have a controlled environment to ensure that the cells within have optimal conditions for the experiment. A successful mission would be to really gain more knowledge that why does the cells change in microgravity.
For this we will collect material after launch to see if genes have been activated towards the proliferation of beta cells.
Actually, my daughter has diabetes, so this is an interesting discussion that I have on a daily basis with my child. I believe that this, in 10 years from now, hopefully, if we are successful in this can lead to that a child or anyone with diabetes can go maybe once every half year to get an injection with treated stem cells and be able to produce their own insulin for a significant amount of time. So this is what we hope for in the future.
Well, you know what to do with it. Get the Jake, the instructor, brings some green baby, some nice
The community is definitely a big thing of it. Everybody who is here has one goal. Everybody wants to have a successful flight and they do everything for it.
It's very interesting to see that astrophysics and rocketman and watchman can work together on the same level, and that's very, very interesting.
And I always love to do these missions and campaigns and to work with people that are so much committed, having this fire in their eyes.
Where else do you have the possibility to do a project which ends in a rocket launch and you can be there and you be part of it?
Woo!
All right, let's go. Officially hand it over to our colleagues.
humans have a need to collect knowledge, and we have a need to collect knowledge together, and that's exactly what we do here.
My new favorite color is blue. It's been that way since I started missing you.
I think it's really amazing because these days you often hear about all the differences between people, all the disagreements, all the wars, but here you have people of like all different continents and countries are getting together to work on the same thing for the same goal, and it's not something you usually see outside of science.
It comes in waves, in waves, in waves, they roll on.
We have a measuring device called a scintillator. It sort of measures particles coming into the rocket and then converts this into
like an electrical signal or light. It emits light.
Exactly.
Yeah.
And then we measure that, and we then, depending on what electrical measure it is, we can determine which sort of
radiation is occurring in space.
Yeah.
And it's getting through to the rocket basically, which is obviously really interesting.
You really worked your butts off getting this project built, and I mean it shows off because you're here now.
Yeah,
it's wild.
These great scientists and engineers, even like wanting to work with us, wanting to talk with us, it's really amazing because when you're 17, you don't feel like you have such a big part in the world. I think we're really grateful for the opportunity.
Here on the screens we can see some people working outside in the tower. They are practicing the late access to see how long they take for the experiments, to see how long they need for the last preparations before the launch. And this is basically the live view on top of the rocket. You can see the nose tip, and this is one level below. So the tower has multiple levels where you can reach the different areas. And sadly, we cannot go out anymore because it's already everything prepared, and we need radio silence if we go outside. So we don't want anything disturbing this.
So, what we're going to see now is the rocket completely assembled.
So here we have the launcher with the foot, and the yellow is the launch rail, and then we have the two rocket motors, base stages on top of each other, and on top, see just a glimpse of it, the payload.
Good morning, everyone. A new week. For many of us, it doesn't feel that actually a week started because the other one never ended. But that's how it is on a rocket campaign. So, but that's also the fun part of it. I need to inform you that we'll not go for a launch attempt tomorrow. That is the current status. which would mean there will be no launch tomorrow morning. Welcome to a rocket campaign. Are there any questions? I guess there are plenty. Either I'm so unclear that you're just confused, or if it's super clear.
The only one information, yes or no? We know that there's no.
No for tomorrow, but you still see me with a smile. You don't see me like hiding behind the board yet. This is how it is on a rocket campaign, and I'm not at this point in time concerned. After 2 years, you will not rush into a countdown when you're not 100% sure that everything is working. Good. Thank you for your attention. Have a successful day. See you later. You still find during the testing like smaller flaws. I mean, these are prototypes which we're flying. Each experiment is a prototype. So it can happen that you find at a certain point like a small error. You fix it, you have to verify that the fix is correct, and then you know that this error will not appear again.
If the weather conditions are such that it's snowing heavily, that the helicopters can't fly, or there is mist in the air, there is risk of icing of the helicopters, then of course they wouldn't fly. So we're confined by the strong winds and the ability to perform proper recovery. So that plays a very strong role.
Hey, welcome everyone. So we'll have this flight readiness review now. See that if we are ready to go for a launch attempt. S3 safety board that we got an approval on the 17th of November. So Arl, Nurbeta,
Yes, we'll go.
Ship,
Go.
Isa,
Go.
Mina Irene, and shell module.
Go.
Recovery system.
Go.
Project manager.
Go.
Mission manager.
Go.
So we approve the ground safety plan, the flight safety plan, the recovery plan. Then I get the last word. Go. We'll pass this around, have it signed. So the plan is now for tomorrow. We will have a show up at 0 to 100. Then we'll have the countdown starting from T-minus 6 hours at 2:30 local time. So that means that if we have a nominal countdown, we'll have a liftoff at 8:30.
And what's the forecast situation?
Good.
Yeah, it's looking good. That's the small version. The short version.
So settings are bullseye. Recovery is not as confident, but as we said, we won't know recovery until it's daylight. So we'll see. So that's how it always has been in the plan. But settings are bullseye.
We have good settings throughout today, so yeah, that's good.
Wow. I have to mentally displace myself from this room and imagine how it is in this situation. And I'd say that it is being nervous in a controlled way.
companies in some way. My name is Science and payload. Science listening. You may switch on the experiment modules and the GCs and start payload check number 1. Copy that.
We have a countdown that runs for 5.5 hours approximately, and there are holds on the way for countdown to make possible for engineers to do the last adjustments controls of the payload. And once we pass all these possible holds, it's wonderful.
Payload from science.
Payload listening.
The module checkouts are completed.
Thank you very much.
As the forecast looks right now, we still have like light clouds in the impact area, no clouds, but they should basically disappear within the next 1.5 hours. So it looks good. And based on that, we have taken a decision to go at this point in time. So we're on go.
Attention, no personnel are allowed to stay outdoors from this point except on the radar hill and chaos. End of message.
Tack så länge. Hans, jag kommer tillbaka.
Har fått ett håll.
Strax innan 9:10 för då.
T-minus 2 minutes.
Experiments on internal power. Confirmed. Confirmed.
Internal power.
Confirmed. Thank you. On the launch day, when I'm sitting in the science center, basically representing the whole science team and all the engineers for the experiments, I have the green and the red button, and after this 2 minutes before launch, I have to decide, are all the systems on go? New Beta, are you ready to go?
Ready to go.
Al, ready to go?
Experiment payload on internal power.
Chip, are you ready to go?
Ready to go.
Chat module?
Chat module is ready to go.
Ready to go.
TLR team recorders running. Service module in flight mode, recovery armed.
That's quite an emotional moment, because you have been working for this for years.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
TLR tracking on main.
Plus 30.
And just a few seconds later, 50 seconds, 60 seconds later, the motors are burned out and our microgravity time starts.
T plus 1 minute.
Start of microgravity. During that time you have enormous tension and enormous concentration, and that's the time then when everybody's turning to their computers and they're looking for the screens and the data coming in.
Recovery sequence seems nominal. Main chute is out.
Willkommen auf der Marsoberfläche. Das sieht aus wie ein Bild vom Mars.
Telemetry, and we are lower in altitude.
Super.
Which there is.
Congrats.
Sì. Questi valori di tutore, ecco
It was scary because we had a huge amount of time without data, and our heart was making it tutum 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 tum. Then the first package arrived. Oh! And you in the science room, you have to be silent, disciplined. Wonderful. We have very good amount of probability to catch the capsule back. Cheers. Okay. Thank you very much.
Okay, so you have this like shoulder mount?
Yeah.
It is time, it's the perfect summer night.
I was fascinated by aerospace since I was a very little child. I remember that my parents took me to the cinema to watch Star Wars, and since then, whatever fly for me is something different.
Yes, I'm gonna try with something
The floor is lower than it seems. It should be in that direction, I think.
You think so? But we had signal down over there.
Ah, okay. I think that we have just to walk a little.
Okay. What do you want to turn? To the right, yeah.
The GPS position is in that direction, no?
Ja, vi flög lite annorlunda för det var för att undvika mål.
Ja,
visst. Tar du in ganska mycket tid?
Ja, det är vi gör. Så två så pass.
But looking at the shape of the ground, we should walk uphill.
The blue one is...
We are blue.
Yes.
Yeah, it changed quite a bit. Like 800 meters.
In that direction?
Yeah, it's...
when we landed, I had the feeling that it was in that direction.
Yeah, because when we flew close to that, we didn't never get to think about it.
I am a dumb engineer, they are the young pilots. But also when the numbers are wrong.
Yeah, that's hard.
Never trust the numbers. Stronger. We'll come back.
You see the reindeers over there?
Great job.
Thanks. I was really happy when I saw it.
Huge. I mean, it is a huge relief. So the moment when we got the message that the payload was back on S range, I mean, then then you're really relieved. Because until the last moment, it's still all about the science. As long as you don't have it in your hands, it's still some tension. But now, when I see a lot of happy faces, all the colleagues seem very happy about the data, so looks great.
Die ist 3 Sekunden nach 2 Wochen und einer Weltraumfahrt. Super. Not too bad, my friends. What a day!
Congratulations.
Yeah.
Thank you. Good job. Really fantastic. So,
I think that when you're this young and when you come from a background with zero like training in space stuff, you don't believe it until you see it. And when I saw it like taking off, I just remember everything that has taken me to this top. And I actually started crying, but it was quite hard to cry in that cold because my tears started like freezing in my cheeks. And I still can't believe it. And we were just joking about it because we were like touching it and disassembling it and just playing it with it. And then someone was like, can we just stop and realize that this thing was in space in like 2 hours ago and now we're touching it? So I think that it still feels like a little surreal.